Hello and welcome to Channels, the Nextflow podcast, where we talk about everything that's new and upcoming in the Nextflow community and the Nextflow world. My name is Phil Yules. I'm a developer advocate at Seqera Labs, and I'm coming to you today from Stockholm in Sweden. I have with us today Chris. Chris, do you want to go ahead and say hello?
Hi everyone, my name is Chris Seqera and I'm also a developer advocate at Seqera Labs, and today I'm joining you from Vienna.
Yeah, new location for you today, Chris. Exciting stuff.
Always changing, always changing.
And today I'm absolutely thrilled to bring back on the show Ben Sherman, software engineer at Seqera Labs. Do you want to give us a quick hello, Ben?
Hey everybody, Ben here, back again to talk about all kinds of crazy Nextflow stuff, I guess. We're running out of topics, but we still got a good long list to go through.
This is good. We're getting into the deep stuff now. This is this the third time we've had you on? Or,
yeah, number three.
Three.
Yeah, we're quickly leaving the realm of things that are nearly done and getting into the realm of things that haven't even been started yet.
So yeah, take what you hear with a pinch of salt, but it makes it all the more exciting for that reason.
Oh yeah.
So yeah, coming to you today, we're recording, but this is going to be going out on July the 31st of 2023, just for some context. So let's get straight into it. Ben, last time we spoke on the podcast, we've had an episode since then, which was about training, which was really, really cool. For if anyone missed that, we had Rob Simon talking to Chris and Marcel all about the different training initiatives going on and what we've got planned in the future. Before that, Ben, you and I were talking about, with Marcel, we're talking about language improvements, where we were talking about cleaning up work directories as you go through a run and kind of optional inputs and outputs for processes and stuff like this. Lots of good stuff. But today our episode is called Talking Tasks. So let's kick off. You're going to tell us a bit about ideas we have for task provenance. What do you mean by that?
Yeah, so I thought we might switch gears and talk a little bit more about what Nextflow is doing under the hood. You know, when you've written there's the language part where you write, and then there's all this stuff, this magic that Nextflow does secretly, right? So this first piece is about task provenance. Provenance is basically, you know, you have a thing, and the provenance of a thing tells you sort of its history or a thing's story. Like, for example, art pieces have provenance, right? That tells you like, well, this piece of art was sold by this person who's then bought by that person, going back and forth all the way back, so that you know that it's the real deal, right? And so the same thing in science. A lot of times bioinformaticians and really data scientists in general care a lot about, you know, for any given data set or file, knowing the history of what are all the sort of transformations that this file has gone through to get to this point. And that's a way of verifying that the file is legitimate, right? Or that it's valid.
I thought you were going to tell us for a moment there that Nextflow is a work of art. And yeah, anyway, sorry, I carry on.
Well, it does have provenance, right? Because it has a Git history. But whether it's art, I guess I'll let you guys decide. But yeah, so provenance is becoming increasingly important, and it's something that we're trying to build out. Like a lot of people may be aware of, there's actually a plugin in development called nf-prov, which is literally about this. And that plugin is about trying to take all of the final outputs that a workflow publishes and creating a giant. I mean, I don't really know all the details of what they're doing, but at a high level, creating like a giant sort of metadata file that lists all of the outputs and what it went through. And the nice thing about Nextflow is that the Nextflow pipeline encodes basically everything that was used to run the pipeline. So, you know, you have a Nextflow pipeline in a Git repository. It has a specific commit hash, right? And then the pipeline code itself defines all the containers, conda packages, other software dependencies that you want to use. So with a single commit hash, basically like version of your pipeline, you have a full description of all of the code that was used to produce the outputs that are generated by your pipeline. So nf-prov is sort of working at that at a higher level. But you could also
that
think
was
about
Bruno, right? Sorry, that was Bruno. I remember talk. Yeah, Bruno
Sage.
Grand. Yeah, that was the Barcelona hackathon last year. I think that was where that started off. I remember having some nice conversations with the two of you back then.
Yeah, I ran into him while I was there, and we started talking about all of this stuff. That was when he was just getting started with the nf-prov plugin, and we were talking about going deeper into this task provenance idea. So imagine that you run a workflow in Tower or wherever really, and then it produces all these output files, right? And then you pull up that output file and you say, give me the list, like the sequence of all the tasks that led to this file, right? And you could actually do that now with everything that Nextflow generates. You can actually do this manually because basically when Nextflow creates these task directories, the work /ab /yada yada, and then like that's the task directory. The input files that are staged into that directory are always symlinked. And so you can look at the input file and you can see its original directory. So it's going to be some other task directory, right? So you go to that directory and look at its inputs and then follow those. And you can keep doing that all the way back to the beginning of your workflow. But so what we want to do is basically automate that, have some way of like saving all that data in a way that is more searchable, so that you could imagine having some interface in Tower where for example, in a run in Tower has reports, right? So imagine clicking on a report, and if it happens to be an actual output file, it actually being able to show you the sequence of specific tasks that generated that file, and then you could go in and you could see all the commands, all the other data files, all that stuff, all the information there, so that you could actually reproduce it right then and there with all that information.
So this is kind of like working back on the DAG, is that right? Sort of picking out where on the DAG this thing was produced and tracing your way back up to a starting point.
Yes, exactly. And this is an interesting part of the implementation, because Nextflow has a DAG. Everybody knows, anybody who's familiar with Nextflow knows that there's like this sort of DAG feature. That is more of what I call it like an abstract DAG, or the workflow DAG, or a prototype DAG. It basically shows all of the processes and operators that you've defined in your workflow. But
we should clarify. Sorry, anyone who's listening who doesn't know what a DAG is as well. This is outside of my comfort zone. maybe Ben, can you tell us what a DAG is, just very in one sentence?
Okay, yeah. So a DAG, that's a directed acyclic graph. A graph in the sense of like a network of nodes. And so when you write a Nextflow pipeline, Nextflow under the hood takes all of your code and constructs a DAG out of it, which is essentially a network. Every process is a node, every operator is a node. And then whenever you connect two processes with a channel, or a processor operator, vice versa, that channel forms an edge, or like a line between the two nodes. And so when you follow this all the way through the entire pipeline, you end up with this potentially huge network that is your pipeline, right? Every workflow manager does something like this, right? Like, Snake, Make, Whittle, all of these tools are doing something like this, whether implicitly or explicitly. And so that's sort of, there's like the prototype DAG, but then you consider that a given process is going to could execute many different independent files, right? Like if you do an RNA-seq, you give it like 1,000 FASTQ files, right? Each of those FASTQ files are going to be processed independently. They're each going to go through this sequence of steps, which is described by this overall workflow DAG, right? But then if you want to think about the task DAG, so all the actual tasks that are executed, that's kind of a different graph that's based on the workflow DAG, but it's obviously going to be much bigger, right? Basically, it's going to be like a duplicate. Imagine if you have 1,000 samples, it's going to be like that workflow DAG repeated 1,000 times. Each one is going to be independent. We'll get more on that later. But the point is that Nextflow does not really construct this DAG explicitly under the hood, because it doesn't really use it for anything. But it does generate all the information required, right? So whenever a task is created, it has all of its input files, and it knows which tasks generated those input files. Because like I said, these files are symlinked in. They're linked into the directory. They're not copied. And so the lineage is all there. It's just a matter of tracking it explicitly and then saving it somewhere. And so, and this actually came up when I was working on the automatic cleanup. This is closely related to this, because in order to know when a task can be deleted, you have to know in this task graph, what are all of the downstream tasks? And then when all those tasks are done, you can finally delete this first task, right? And so this effort sort of sprung out of that while I was working on that. And then now it's become sort of its own thing, is like, well, let's just save this task graph somewhere. Initially, what I was going to do was basically save just like a JSON file to every task directory that just lists all this metadata, like the hash, the input files, the output files, the upstream tasks, and so on and so forth. But then, of course, that kind of directly clashes with the automatic cleanup, right? Because then if you have cleanup enabled, all that information just gets deleted. So we needed to find some other way to do this. And the answer to that is to save it in this Nextflow cache. This is sort of a more obscure feature that people don't know as much about, but you may have noticed whenever you run a Nextflow pipeline, it creates a .nextflow folder in the plate wherever you launched. There's a .nextflow folder in your home directory. That's something different. This .nextflow folder that's in your launch directory stores a sort of a cache of all the tasks that have been run. So to resume a pipeline, you actually need both the .nextflow folder and the work directory, which is a little bit confusing. It'd be kind of nice if you could just, have one or the other, right? This might actually allow us to do that, because basically what we can do now is every time a task is executed, the metadata about it is saved to this .nextflow cache, right? But currently that cache doesn't include information like the input files and output files, like just the names and paths and stuff. So if we could just store all that information, then that'll just be in there. And then if you have your cleanup enabled and you delete your work directory, all that information can still be, recovered in that Nextflow cache. And so then the question after that becomes, how do we build an interface on top of that to like query that cache? I think there will probably be something we'll try to do in Tower. Like I was saying before, like maybe you have a run in Tower and there's some button you can click somewhere to look at the provenance of a task, and Tower under the hood will just be pulling up that .nextflow cache and querying it because it's just a file.
The main reason I know the .nextflow folder is I think if you do Nextflow, I've forgotten it now. What's the one there's a one that lists all the previous runs you've done in that directory, right? Nextflow.
Yeah, I think you're thinking of the log command.
Nextflow log.
Yeah.
So that can list all of the runs you've ever done, and then if you select a specific run, it'll show you the tasks within that run. Yeah, so all of that information is coming from this .nextflow cache. It's just querying that. So it will be much the same thing, but actually being able to look at just more details, right? The inputs and outputs, and from that, the provenance.
I'm already hopping ahead and thinking like, it'd be great to have an HTML report listing all the files, and you could click on them, and it'd be all super interactivity. You can fly through 3D space, and maybe I'm getting ahead of myself.
I'd love to have something like that.
I guess actually saving the information somewhere and making it accessible is like step number one. So
so maybe when we actually get it implemented, I'll let you know, and then you can go to town on that. I'll show you how to query the tasks, and then you can make a beautiful little HTML report that'll probably be like a gigabyte in size, because there's like 10,000 tasks, and you gotta
completely impractical. I like it. So just to clarify a couple of things. So when we started off with an introduction talking about Bruno's plugin, the nf-prov, but this is the core Nextflow feature, and it's instead nf-prov was like at workflow level, and this is a core Nextflow feature which is at task level. Could you just clarify where the boundary sits between those two just slightly? I know we talked about it a little bit.
Yeah, I guess the way to think about it is like more fine-grained versus coarse-grained. So I think I said earlier that like just the workflow level provenance that nf-prov does, where you run a pipeline, it publishes all these outputs, and then now you have all these output files that are tied to that workflow run. For a lot of people, that should be sufficient because of how Nextflow encodes all of the information about the software that it used, right? So for a lot of people, that might be good enough. Like for the FDA, that's in a lot of government organizations, that's probably good enough because that you can go and verify it from there. And I guess the reason why nf-prov remains as a plugin is not something that I don't know if it's something we'll ever like incorporate into Nextflow, is because it's sort of a custom report, and so different people might have different requirements about like what exactly they want that provenance report to look like. And so it's better for it to be a plugin. All of the basic primitives exist in Nextflow, so it's very easy to basically sort of like roll your own version of nf-prov. But then for the task level provenance is just more detailed. So it's like, I know that this file was produced by RNA-seq, but I want to see the exact sequence of tasks and commands that were run to produce that file. And I want to be able to query that easily. So I could do that with nf-prov now, but I'd have to go through all these task directories by hand, right, and trace all that myself. So with the task level provenance, honestly, it's much the same strategy. Like in Nextflow, we're probably only going to build out just saving the data in a standard format. And then if somebody wants to create a report, then it should be pretty easy to create a plugin that, queries that data. And then we may do our own kind of thing in Tower, right? Phil will do his own thing, right? And then, if people coalesce around the common standard, we could certainly do that. But for now, just providing the data, and then we can let people experiment and see what cool things they come up with.
On that note, I remember at this hackathon in Barcelona last year, I remember the great thing about hackathons is just you get everyone in one room and you have a conversation. You're like, I was just talking to someone over there about this, and you kind of have all these people come together. And so I remember Bruno, I remember you yourself, and I remember there was a few guys from a company, Quilt Data as well, who were at the hackathon and were also interested in this idea of provenance. And I think their software works with these sort of data packages, and maybe has some aspects of overlap here. I remember they were talking a lot about provenance as well, and maybe standards. Do you know what I'm talking about here?
Yeah, there's something to this. I can't quite put my finger on what it's going to look like exactly, but yeah, it was funny because at the hackathon, Bruno and I were kind of in a room to the side, and then the third person in there was Dr. Ernie from Quilt, and so it was really funny having all of us in there. But yeah, like there's a lot of potential overlap, I think, between what nf-prov is doing and what Quilt is doing. Actually, they're basically doing the same thing, right? Because nf-prov is you run the pipeline and it generates this metadata report of provenance at the end, right? And then we have a Quilt plugin that does much the same thing. At the end of the run, it collects, the list of all the files that were published, and then it pushes all of that to a Quilt repo. And a Quilt repo works a lot like a Git repo. It's versioned, it has a history to it, but it doesn't really hold any data. It doesn't hold any actual data or files itself, just sort of metadata, and it points to actual data in S3. And so that way you can just have a nice decoupling there. But then there's the Quilt. There's like a Quilt website where you can go and browse these Quilt repos like you would on GitHub. And they have all these nice viewers, right? So, you click on a link for like a plot or HTML file or a CSV file, and it renders it in a nice format. Again, kind of like what GitHub does. What we want to do is have some kind of integration here where, you can use Quilt and Tower together, or Nextflow and Quilt together. But I think Tower and Quilt is probably the most like supercharged version of this, right? And your workflow runs are automatically saved in Quilt, and then a Quilt repo could potentially be used kind of similar to like a Tower data set. You know how you can launch you could launch a pipeline in Tower and specify a data set instead of just giving a raw path. Something like where you could specify like a Quilt repo and launch a pipeline from that. and then the pipeline itself is generating a Quilt repo. And then you could have these chain of repos that represent, a sequence of pipeline steps. It's workflows all the way down, right? So it's just provenance at a higher level.
This is one of those conversations where I feel like we're getting more and more meta. It's kind of that's good though.
Yeah.
I think the next podcast we've got going out actually is with Harshal and Evan. We talk a bit about Tower, and we touch on data sets and stuff. So there's overlap here as well. And I think this is a great example of where working in the open, as we do with Nextflow, and you get all these synergies with people. All three of these projects are very similar with some overlap, but slightly different kind of goals and outcomes and stuff. And it's great that we can get everyone together and kind of collaborate on standards and cooperativity and
Yeah. And to be honest, I wish we would have made more progress with Quilt by now. But I guess there's just been so many things going on. I think one of the challenges still is just that Nextflow, there still isn't really a good sort of standard around how to define workflow level inputs and outputs in Nextflow, right? Like you have params, and then you have the publish year directive, but that's defined at the process level. There isn't really a good way to just get a summary description of this workflow has these inputs and outputs, right? And so I think we're going to have to figure that out first, and then maybe the integration with Quilt and all this provenance stuff is going to be a lot easier to actually make accessible to everybody. That whole concept is we'll save that for another episode.
I was going to say, let's save that for another episode, because you've got my mind racing about chaining pipelines and all kinds of other good stuff like that. But let's not go down that rabbit hole straight away. Yeah. Cool. All right. Anything else to add on provenance and tasks? I feel like we're probably pretty much saturated that one. Happy, Chris?
Yeah, I'm happy. I'm just sitting in awe. Really excited to sort of see this provenance feature get off the ground. I think it's going to have a great sort of use, and it will have so many applications down the line as well. I think it's just a first step to enable so much more. So yeah, I'm really excited to see where this goes.
Yeah, foundational stuff. All right, Ben, take us on. What have you got next for us?
Okay, so sort of a related concept. So I've talked already about how this provenance idea is related to that we have this .nextflow cache, right? Which is a much more compact way of caching tasks. This is something that literally just came up like a week ago. Apollo had this idea, and then I implemented it. It's basically what if we could store this .nextflow cache in object storage instead of just having it local, because it's clearly very important to resuming a run, right? You can't resume a run without it. But the problem sometimes is in Tower specifically, for example, suppose that you launch a pipeline on any cloud platform really. So that the head job is running in the cloud. Tower has to save that .nextflow cache at the end of the run so that you're able to resume later on. But if something catastrophic happens where the head job is killed before Tower can do that, well, then you can't resume the run. And so all your progress is lost. And then I think there's also other problems on Azure and stuff where sometimes that cache, the saving and restoring it can be flaky. And so the idea we've had is, why don't we just save this whole cache in object storage to begin with? Because we're already having to save it and restore it between S3 or whatever platform we're on, right? So let's just do it from the get-go, and then you don't have to do that. And then on top of that, you get the scalability of S3, right? So, think about what happens when we start storing all of this metadata so that we can do provenance in this .nextflow cache. That's going to make it grow a lot more. That's also something that's necessary for the automatic cleanup. This just keeps coming back up, right? That in order to, because the automatic cleanup can work just fine, but if you want to do the cleanup, but then also resume with those directories having been deleted, all of that information that you deleted in the work directory, well, not all of it, but some key pieces of it need to be in the cache, so that when Nextflow is trying to resume a run, it comes to a task directory and says, I should have this directory, but it was deleted. So then I'm going to check the cache then and see if I can recover things like the exit code and just the names of the inputs and output files, and not the content, but maybe just like the size and the like a checksum, so you can verify it.
Especially if, I mean, like, people run Nextflow workflows with millions of jobs and millions of inputs sometimes. I can imagine this quickly being like support requests being like, oh, I was running on my on AWS and my like local storage maxed out and everything crashed, and also pre tower as well. I remember running on like batch squared, just native AWS without any tower stuff. I remember the fear of having the head job running on this ephemeral EC2 instance, and if you ran that with Spot and it died or whatever, like the ability to resume was much more fragile back then.
Right, and a lot of people complain, and especially in the HPC world, one of the downsides of Nextflow is that it creates all these little files in the work directory, right? And that puts a lot of strain on, the shared file system that people are usually using. We probably can't change the fact that Nextflow is creating those files in the first place, because that's how Nextflow coordinates with tasks. But the least we can do is to delete them as soon as we can, so that at least, we're minimizing the total number of files that are existing. And in order to do that, we just have to lean much more heavily on this .nextflow cache, which makes a lot of more sense, right? Because it's much more compact. It's basically a single file. And if all you need is like to write a little bit of code, and then you can query that data, and then you can build whatever interfaces or reports on top of that you want. And so this is the same idea with an S3 cache, is that we're just storing it in S3. So everything is automatically there. We don't have to do all this like backup and restore. And then it's maybe a little bit easier to query it. You just need, you could imagine having like a Nextflow command, right? That just where you do some kind of query against this could be what the provenance looks like, for example, and then it would just query against S3. So there's just a lot of potential reliability and scalability gains to come from that.
One question on this, I mean, object storage, you typically can't kind of necessarily write directly from a file. You have to, so like, how are you coping with that? Are you kind of pulling the file, making changes, pushing it back, or is this using Fusion only, or is it got some other kind of clever tricks, or am I completely overthinking it?
So yeah, so you can't really do like random access reads and writes. You have to basically read the whole file or object, or write the whole object. The way that we implemented it, this sort of relies on some magic that Nextflow has under the hood, where it's so first of all, I'll say this: the way that the database is structured is that basically there's an S3 object for every like task, right? And that task entry is written once at the end. So that part is simple, right? Because basically every time a task is done, you just write that one object. That's not a big issue. The other issue is that there's this index file, which just basically is like a sort of like an append-only log of all the tasks that have been executed. I don't think it's strictly necessary for like Nextflow to work, but it was just easier to implement that just to match the existing, like the default cache we have. So in that case, you're appending like a new line every time a task is created to this file, right? So I think what Nextflow does, if I understand things correctly, is that I think it just does like a really long running multi-part upload, which is kind of magic. I think this is more or less what Fusion is also doing, right? So when you're using Fusion and you're writing files, in reality, you're probably streaming data into this file, right? What Fusion is doing behind the scenes is just doing this like really long streaming, like multi-part upload. I'm pretty sure that's how it works. You'll have to have Jordy on. And maybe
I was going to say, we need to get Jordy on to talk about Fusion. I've got that pencil. I haven't asked him about that yet, but I need to get him on at some point to go in depth on how. I don't know how Fusion works. It's just a black box of magic to me.
Yeah, same for me. But that's just basically the point of all what I'm saying is that it does not have to like re-upload this little index file over and over. It's streaming it somehow. But even that is a very small part of how the cache works, right? So like 99% of this cache operations is just writing a task entry to an object, reading a task entry from an object, And that is very straightforward.
I'd sort of naively imagined like a 6 gigabyte JSON file, which we were downloading and re-uploading like every few seconds or something.
Yeah.
It's a bit more sensible than that. And just in case anyone listening and doesn't know what we were talking about a second ago with Fusion, that's another one of the products that's come out fairly recently from Seqera, which is for treating S3 basically as a local drive. So we're saying you can't write directly to an S3 to an object storage, but with Fusion you sort of can. So there's a few systems like that around there at the moment, and this one is paired with Nextflow and makes life a bit easier when you're running on cloud basically, and also not just cloud, local. Pretty cool stuff, then. Especially, I think probably the one that the part of that sticks with me the most is that my precious dash resume is going to be that bit more like resilient. That's
because I've always found it annoying that the resumability is split between this .nextflow cache and the work directory, right? Like it should just be one or the other, ideally. So I think that we're always going to need both to some extent, right? But I think the dream of what I want to be able to do is you run an entire pipeline, it publishes all of its outputs, right? And then you just delete the work directory entirely, and then you try to resume it. And then it's able to resume everything from the cache, and it resumes all the way down to the end of the pipeline. And then at the end, when it's looking for these outputs, it just checks basically the published outputs. It has a checksum. It takes a checksum from the cache. It verifies that against the published file checksum, and then they all match up. And it's like, good. Well, you're all good to go. I don't have any of the intermediate results from this run. They're all gone. But as far as I can tell, it looks like you've already done this run before. So we're just going to call it all resumed and be done for the day.
It's going to be the acid test, isn't it? Can I RF this and it still works?
Yeah.
Awesome. All right. Let's take us on to the third and final chunk then, if you will. We've got written down here that you're going to tell us a bit about task grouping and sub-workflow or workflow grouping.
Yeah, so we're starting to get into magical mystery territory with some of this stuff. I'll split it in two pieces because the task grouping and the workflow grouping are kind of separate things. So the task grouping, we've talked on here before about array jobs, right? And how that's sort of, you're still, an array job still runs all the tasks independently, but it's just submitting them in a batch. So that gives some relief to the scheduler, right? Task grouping is where you actually take a batch of jobs, a batch of like Nextflow tasks, and actually run them as a single job. And so I've implemented this. It's like, I would say it's like 95% done. And then there's just a little bit of testing we need to do with the cloud platforms. But basically what you imagine is that, say you have a process and you say, I want to do grouping of 100 tasks per job. So then what Nextflow will do is for every process, it'll wait until 100 tasks have been created. And then it will, set them all up. And then they still all have their own directory in the work directory, right? Their own, command.run, command.sh script, all that stuff still gets created. But the actual script that gets submitted as a job to the executor is sort of so there's like 101st directory that's created. And the script for that job is to basically loop through all of the child tasks in a for loop, just one after the other, run this and this and this and this, and so on and so forth. And then finish. And then at the end, Nextflow will actually go back through all those directories and make sure they all completed correctly. If any individual children fail, it won't kill the whole job. The task group will basically say, okay, well, we'll just skip that one and keep going. So it'll try to complete as many as it can. And then at the end, when Nextflow checks all the results, it'll go and retry any of the children that failed for whatever reason. And they'll be retried in, some new group with new children, right? And it'll just keep doing that until it succeeds. So I think we can do this in a very stable way. And the benefit of all this is that in cases where you have these like really small tasks where it's like, like write a single line to a file or something stupid that takes like 2 seconds. Normally, running this on an HPC scheduler or a cloud provider is just stupid, because you have to spin up this whole job or an entire VM, and then you run your little 2-second task, right? And then you tear it all back down. So in cases like that, it's much better to just put them in groups of 100 or 1,000 or however much you want to do. What people have to do now is basically do that manually. And you can do this manually, where you could do some channel logic saying like, okay, use like the buffer operator or something, or the collate operator, to group all the inputs into like groups of 100 and then process them all. And then you write that for loop yourself in your Nextflow process, right? But this should really be something that can just happen automatically, right? Yeah. It's like configurable. So
I was going to say, I think like I've seen this support request come up pretty much as long as I've been using Nextflow, to be honest. I've seen it as reasons that people use different workflow managers, is because if their workflow loads, because I mean, the three of us come from a background in genomics, and we're used to these tasks which run for hours or days and gigabyte files, but a lot of the kind of data science world is not like that. We're running small repeatable tasks, iterating, things like that, and it just doesn't really fit with this model. And then as you say, spending 5 minutes to spin up a new instance just to run a 2-second job becomes a serious problem if you've got a million of those.
Yeah.
So, and I was going to say, I think we have got the Nextflow patterns website on the nextflow.io website with common patterns, and I think this is one of them. What you mentioned there, of like kind of grouping together the inputs into a bunch, and then just having a process with a bash for loop, which always left me feeling a bit unsatisfied somehow.
Yeah, that was actually a pattern that I wrote to sort of tide people over, until we could come up with a more native solution. But it's actually very straightforward. I think once we figured out how to implement array jobs in the way that we have, the task grouping is extremely similar. There's only a few minor differences, but then it works basically the same way. So we were able to knock that one out really quickly. And so I'm still doing some testing on it, and then, well, who knows when it'll make it into master branch, right? But it is it's nearly done.
I've got a horrible question for you straight away, which I didn't prepare you for at all. But you said that these tasks are looped through kind of just in a simple loop, basically. I'm thinking a little bit about how the Nextflow local executor works, where it's a bit more clever than that, and it knows roughly how many CPUs are available and things, and it can parallelize tasks even in a local setting, like on a single server. Is there any way that we can do that within a task group? We say, okay, this instance I've been put on has this many CPUs, this much memory. I can do 10 of these simple jobs in one go. Or is that out of scope, or is it something you've thought about?
So I think you could work all that out with what Nextflow currently has, in the sense that like you could say, I want this process to execute in groups of 100. And then if you say that this process has one CPU, then what you're saying is that this entire group will have a single CPU. And I think that will probably be the best way to approach it, is just have the local task, just give it one CPU, and then that CPU, iterates through all of these, and then Nextflow will parallelize at a higher level, right? So then it'll see that your laptop has 8 CPUs, and say, well, I'll just, for every new group that comes in, each group will get its own CPU, right? And I think that's probably sufficient.
It makes sense. So we're still parallelizing, but just we're parallelizing the groups instead of the tasks within a group. Yeah, I get that.
Yeah, I think this is like just a general bit of advice with parallel programming is always try to parallelize at a higher level if you can. Sometimes you can't always, because you might have some more overhead when you do that. But in general, it's much easier to parallelize at the level of like different Nextflow tasks, right? Rather than trying to, within a single Nextflow task, use multiple CPUs and parallelize around that. Sometimes that might be more efficient, but whenever it's not, just let Nextflow do it for you, right? And one interesting piece with the local executor in particular is I'd like to have the ability to have, say, well, actually, actually, no, we won't talk about that here. But I'll just say with local executive in particular, I think that's the most common case when the task is really small, is when it's like some little local task that you have to run. So I think that's probably the one that will benefit the most, because then you could have this task that literally takes like a tenth of a second and probably only uses like a tenth of a CPU, and then do 100 at a time. I guess that's the thing about it, is like, if a task if it needs less than one CPU, like it literally needs 10% of a CPU, then it would be nice to be able to actually say that in Nextflow, is like, this task uses 0.1 CPUs, and then Nextflow would automatically just throw like hundreds of these little tasks at your system. But that's a separate problem of allowing fractional CPUs, which again, we'll save that for another episode.
Sorry, I blindsided you with that one a bit. Chris?
I just wanted to ask, from a developer perspective, how will this be organized in your workflow? Will this be like a directive, or be something that you try and sort of add with a process selector, or just something at the workflow level?
So yeah, this would be a directive, probably just like group or something like that. You just say like group 100, and that will tell that process to group it that way. The same way that we're doing for array jobs. You just use, we have a directive called array, so you'd say array 100, and then so probably you need to pick one. Like, you need to do array jobs or do group. I don't know what it would mean to do both at the same time.
Well, that's cool, because that means it's going to be easy for an end user to customize this as well. If their particular system or the number of files they're working with and stuff, they can decide to group at different levels within their.
Yeah, that's how it should be, right? Like, you should be able to define tasks at exactly the granularity that you think makes the most sense to you, and then use process directives, which is a very declarative way of, it's just sort of like, it's just like pluggable behavior, right? Like, let me just plug in this little bell or this little whistle, and then it should just work. You shouldn't have to like rewire your entire pipeline just because you want to optimize things differently, right? It should just be something that, it should just be a setting. So that's the dream. That's what we're heading towards.
I can also imagine that another group of people who are going to really like this is everyone who, like me, has grudgingly had to try and write something in Groovy because it would be too slow to run it have this whole VM, and I'm like, right, come on, Phil, I can do this in Groovy. I don't have to resort to Python. But now I can just go back to Python because you're gonna group everything together for me.
Yeah, you just have to deal with all. It's probably fine. That's what Nextflow's for, right? Just wrapping your scripts in more and more layers of bash. Just add another layer, right? That's always
and the other thing I want to, again, you said this kind of in passing, but I just wanted to trying to find the edge of where this goes to. This is per task, so we're never going to be able to group together different processes or tasks from different processes within a single group.
So it's possible in theory. We'd have to implement some logic in Nextflow to verify it, because the main thing you have to do at that point is whatever tasks you group together, and this is true for both array jobs and for task groups, they have to use the same container, and they have to have the same resource requirements, right? So if you had a group of 100 and 99 of them need 2 CPUs, and then, so let's say 99 of them need 2 gigs of memory. This is the one that really matters, right? And then one of them needs 8 gigs of memory, but you put the group together and the group uses the 99, the 2 gigs of memory, then, that 100th task is going to fail. So, I think it's something that we'll experiment with as a second phase. This is something that Paulo is interested in, so it's probably something we'll look into. But it just kind of depends on all the processes in your pipeline, how homogeneous they are. I've written pipelines before that were basically just wrappers around Python scripts for like machine learning stuff, where basically all the steps have the same container, like same software dependencies, same resource requirements. And so in that case, it would probably be fine. But then, a lot of these bioinformatics pipelines like RNA-seq, like every single process is different requirements, all this stuff. There probably isn't a lot of low-hanging fruit there. But Yeah, we'll just have to see.
It was machine learning I was thinking of. I think that's one of the places we often see people talking about these kind of fast tasks which can't be grouped because of iterative changes. Which, of course, one of the things that Nextflow is great at is being able to change the runtime parameters as it goes along, which a lot of other workflow managers can't do.
Right.
Anyway, I digress.
Okay, so the other piece of this that I wanted to get into was this idea of workflow grouping. I also call it vertical grouping, and I hope that I can explain this in a way that people will understand. So I think of task grouping as sort of a horizontal grouping, because I think it's basically because like whenever I look at pipeline DAGs, they're always rendered from top to bottom, right? Like Nextflow DAGs, if you look at it, it starts at the top and goes all the way down. So I see, like different independent tasks, I see them as being in like a horizontal line, right? If you're processing like 10 different FASTQ files in RNA-seq, I see them as being in a horizontal line. And then they're each going through this same sequence of steps, right? One after the other. So I see that sequence is going top to bottom. So the task grouping, I call it horizontal grouping. And then vertical grouping is this idea of consider an individual input file that goes through all these steps in RNA-seq, right? Like the FastQC, the trimming, alignment, quantifying, all that stuff. That sort of forms like a vertical chain, right? Imagine if we could take that vertical chain and run it as a single job. So now we have a job that's processing a single task, but it's doing multiple Nextflow steps, one after the other.
This is taking us. I feel like we're going full circle on the episode. We're coming back to our provenance thing with our duplicated DAGs again. This is like sort of the same thing, right? You're saying each one of those duplicated DAGs is basically then could be processed into a single job submission.
Right. So, yeah, I didn't consider how this would come around that way, but you're absolutely right. So yeah, so there's this like two different dimensions around which we could do this like grouping for efficiency. And this vertical grouping can be very useful when, suppose like with this example, maybe you only want the final output of the expression data that you get at the end of RNA-seq, and you don't care about all of the BAM files and trimmed FASTQ files that you get in the middle. You're just going to delete those as soon as you can. You'd like to have this automatic cleanup feature so that you could just delete it as soon as possible, right? But imagine if you ran that entire vertical chain as a single job, you wouldn't have to do any automatic cleanup on that stuff in the first place, because it wouldn't be copied back to the work directory at all. It would run that entire sequence, and then only the final output would be listed as treated as like a process output that will be copied back to the work directory.
This is like running with Scratch directive, right? Where you're using like local Scratch disk instead of going back to the work directory,
yeah.
But like on the next level.
Yeah. So this is really this workflow grouping is really supercharged when you use it together with Scratch storage, because then you're using the local storage, which is much faster, and you're significantly reducing the amount of traffic that's going between the shared work directory and the task node. This is one of the greatest bottlenecks of Nextflow, and it's such a core design choice that we can't really get away from it. And it's fine. Like, it's a good thing that this idea that Nextflow uses this work directory to coordinate all these tasks, right? So we don't have to maintain like a database or all this other crazy stuff, right? But then the downside of that is that this shared work directory becomes a bottleneck where all of these tasks are constantly uploading and downloading data between this work directory. We can't eliminate that entirely, but we can minimize it a great deal. And this workflow grouping is one piece where we do that. This is actually something that we implemented when I was in grad school. I was working on a project called GemMaker. I don't know if you remember this pipeline or not, Phil. But
I remember the GitHub issue where you talked about it.
Yeah, GemMaker is basically RNA-seq. It does all the same stuff. But the reason that it exists and why the authors haven't just switched over to RNA-seq is because they had a lot of scalability problems where you'd run this RNA-seq pipeline on thousands or tens of thousands of tasks, and you would just take up all the storage on your cluster. I literally did this once. I tried to run GemMaker on something like 10,000 Arabidopsis samples, and I filled up our Scratch storage that had like 100 terabytes or so on it. So the sysadmins were emailing me being like, there's like 32 megabytes left on this Scratch drive, this 100 terabyte Scratch drive. We're going to just delete all your stuff so that it'll free up. And I was like, fine, I didn't mean, I'm sorry. But, and so in GemMaker, we came up with all these clever ways to deal with that. One of it was this like automatic cleanup trick that you're probably familiar with, where we would delete the file contents, but we would preserve the timestamps and the sizes so that Nextflow would cache it, and that sort of worked. And then the other piece, which was something that I experimented with, was I basically took all of the steps in the pipeline and I manually combined them into a single process. So there was just this one process called process_sample that just implemented all of the steps, all of the logic checking, like are you using like, which aligner are you using, and all this stuff was just implemented in Bash. And this was great because it would take the FASTQ file and then it would output the final expression data, and all those intermediate files could be immediately discarded. They never caused the problem. They didn't have to be written back and forth with the work directory. And so again, this is what I was saying, like I was saying before, like you can implement, just like you can implement task grouping manually in your pipeline with operators and stuff. You can do this vertical grouping too. You could just take, a sequence of processes and just combine them into one process. But again, the pipeline developer shouldn't have to do this just as an optimization, like when they're trying to make optimization choices. They should just be able to set a directive, just switch it on or off, and then it automatically does that, right? So yeah, this is the idea. I'm wondering what you guys are thinking so far.
I'm wondering, are you going to break resume? That's the first thing that jumps to my mind. If we're not copying to the work directories, then what happens if it's, get halfway through this sub workflow for one file and everything crashes down? What can I do about it?
The eternal question is, will it break resume, right? Well, yeah, so this depends mainly on how we implement it. I think there might be a trade-off here between resumability and this sort of minimizing data transfers that I was talking about. Because one way you could implement it is that Nextflow just executes it as a single job and then saves the final outputs to the work directory. And so in that case, you've eliminated a lot of intermediate data transfers, right? But then you've also, I guess you actually could still preserve resumability, right? I guess you would do a similar thing to what the automatic cleanup is doing, is that so Nextflow would have to understand that when it gets to this sub workflow, it looks at the first step and it says, okay, the outputs for this first step are missing, but I know that this was executed as part of like a fused sub workflow. So I'm actually going to skip ahead to the last step and recover the outputs there. So actually there might not be a trade-off. We might just be able to have resumability for everyone. That would be great. So I guess
worst case scenario. Sorry.
What?
I was going to say worst case scenario. I sort of feel like this has probably got enough benefits in certain use cases that people would be happy to make that trade-off as well, if it's clear.
Yeah, I think so. But yeah, I guess in general, I'll say that it's just a matter of it really all just kind of comes back to provenance, doesn't it? Like it's just a matter of keeping track of which inputs and outputs went where. And even if you don't have the actual output files, if you have the hashes, so you have sort of a fingerprint of them, and you have the provenance of which tasks were followed by others and so on and so forth, you might be able to do it. Now, so actually there is one thing to say about resumability, which is that if a task failed halfway, and this was like a fused sub workflow job, right, then you'd probably lose the entire progress of that task. And in this case, there is a trade-off, because you could implement the grouping in a way where you still have all the separate task directories for each step. And then in that case, you might be able to recover halfway through this task. But in that case, you have to send all that data back to the shared work directory, right? So there is a trade-off in the case of like resuming failed tasks, but just resuming a pipeline in general should still work.
I'm thinking out loud here, which is probably not the right place to do it. But I mean, if a task fails, but that sort of job is still running, the meta job is still running, could it recognize it's failed and then copy out all the work directory contents for all the steps up to there? So at least you could carry on using the traditional work directories. I mean, if that whole, obviously, if that whole node or whatever gets killed without warning, then there's nothing you can do. But if a task fails because of something within the pipeline, could Nextflow be like, okay, I'm just going to save all the work directories for up to this point? I'm just giving you more work now.
This also comes into how it's implemented. So I guess I should say this. The main thing that I haven't figured out about workflow grouping is what does like the job script actually look like? Because if you have a string of processes one after the other, then in that extremely simple case, you could, in theory, I'm just literally going to concatenate, all of these scripts together or something like that. But you could have data flow in between them. You could have operators and stuff. So if you wanted to support arbitrary sub workflows, I think what we would really need to do is run Nextflow in Nextflow. So Nextflow would submit a job, and then that job would actually launch Nextflow. And it would just say like launch starting at this specific sub workflow, kind of like the entry flag that we have, right? You can give it like a specific sub workflow that you want to start. You would say something like that and provide it just the inputs for your little vertical slice, right? And then it would do that. I still don't really know like what that will look like. Like will it like actually launch its own instance of Nextflow? That's tricky because it's going to have its own session ID and cache and work, and all this stuff is going to be separate. Or do we have something where like we launch Nextflow like in some kind of server mode, and then we just send Nextflow a task whenever we want it to launch a sub workflow, and then it just runs that? There is actually some infrastructure in Nextflow already. People may or may not know about this, but there is a hidden command called the node command. You can say Nextflow node, and that will start up Nextflow in server mode. This was originally made for Apache Ignite, which kind of depended on something like that. It didn't really go anywhere, but all of the code is still there. It's like a little ghost code. So we might be able to resurrect that code and repurpose it for this. And this is why I think this whole sub workflow idea is really just like, feels like dark magic. It's like necromancy. Like we're literally raising up dead code to try to repurpose it as all this stuff. So there's still a lot of questions to answer on the implementation side, but if we can get it to work, like I said, massive gains for data storage. And then I'll be happy personally because between that and automatic cleanup, we can retire GemMaker and they can finally join the fold with RNA-seq, right?
Yeah. And I'll be happy because everyone who comes in with this question on Slack, I can be like, yes, you can do that. Yeah. I'm glad that we touched on turtles all the way down earlier. Now we've got like an inception moment where I feel like, how many levels deep does it go? Nextflow in Nextflow in Nextflow.
Yeah, like what happens if you group a sub workflow and then that has an inner sub workflow and you decide to group that one? It's like, this could get pretty hairy. We might have to put some limits. Like you can only have one group, one level of grouping, Awesome. And then what happens if you take a sub workflow and you group it, and then you do horizontal grouping on that sub workflow? So now I don't want you to just execute this one sub workflow as a job. I want you to do like a task group thing, but where each task is actually a sub workflow and iterate through each of those. This stuff can get pretty insane. So, but I'm excited. This is the kind of stuff that gets me excited to work on Nextflow.
At some point, you want to just print out a log message saying, look, just run it in local mode. just give up. No.
Just use Tower.
Good stuff. All right. Well, my brain is starting to overheat a little bit at this conversation. I don't know about you, Chris.
Mine too.
But it's some seriously cool stuff. I think this is going to make a big difference. Like I say, this comes up an awful lot in the community, so I think it's going to have real impact if and when this ever sees the light of day. I hope it will.
Good.
Yeah. Chris, anything to add, or do you want to take us on to a couple of our kind of staple points?
It's super exciting. Like I said earlier, and I think it was really cool that this whole episode is kind of cyclic, that we've gone back to the start with the data provenance and keeping track of everything, how that's all really coming together. It's pretty cool stuff. I think we have just hit 1 hour though, so I think we all wrap things up. What I was going to mention is just the upcoming events. So we have the Nextflow Summit in Barcelona and Boston. So from the 18th to the 20th of October, we have the summit in Barcelona. Of course, prior to that, we also have the NF Core Hackathon, which, as you've already heard, it's a really great place to share ideas and get in touch with people like Ben if you want to talk about things in greater detail. We also have the Boston Summit, so that's the 28th to the 30th of November. This is the first time we've had a summit in Boston. I think it's really exciting as well. And we do have a 1.5 day, I think it's 1.5 day hackathon before that as well. So it'll be the 28th, 29th, and the 29th, 30th will be the summit. Abstract submissions for both of those events are open. So if you are interested in attending and want to submit an abstract, there's places for posters and talks. So do get those in. We've had some really good abstracts come through already, but I'd love to see some more.
Please get them in. It makes us so stressed because everybody is like, yeah, I'm going to put an abstract in, and then everyone does it in like the final weekend. And poor Chris and I are sat there going like, with like a week to go, thinking there's not enough.
Yeah, trying to put together a program with a handful of talks, but
80% come in the last 24 hours or something. So please, just if only for us, get your abstracts in soon.
Make us happy.
Yeah.
Of course, as well, we do have the community training events coming up. So we have a foundational or fundamentals training from the 6th to 8th of September. It's all online, so you can just register for that to be kept up to date. And also from the 27th to the 28th of September, we have the first advanced Nextflow training. So this is the content that Rob Syme spoke about in the last podcast. This will be the first time this training material has been sort of given or shared with the community. The registration numbers for this are tracking quite steadily up. It's really exciting to be able to share this with the community. So please do register and come along if that interests you as well.
It's cool as well. The advanced one is a local site in Cambridge in the UK, being hosted at Wellcome Trust, Sanger Institute and EBI there. So if you're in the Cambridge area, have a look. I think it's open to anyone. So even if you don't work there, you can still drop by. And anyone who came to the March hackathon will remember that we did all these local sites all over the world. This is totally organic. They told us they were going to do it themselves anyway. But if anyone's interested in doing local sites for training, let us know, because we'd be happy to kind of help out with that. And doing stuff in person, if you can get a group of people together in a room, is always a bit more fun than just sitting by yourself, and a bit easier to not be distracted by those emails. All right. Anything else? I don't think we've got any new blog posts or anything, or I think we're...
No, not yet, but I think there are a few in the pipeline, but I don't know if they're quite being published yet when this podcast goes out, but do keep an eye out for those.
Yeah. Good stuff. Ben, thank you for your time. It's a pleasure as always. I think when you wrote up the notes for this, you put runtime part 1. So I'm already looking forward to what you've got in store for us for part 2. This is like, it leaves us on a cliffhanger. Hopefully everyone who's listening as well hit that subscribe button.
Yeah, just wait for language part 2. That one's coming too.
Oh yeah, so much stuff in the pipeline.
Oh yeah.
Great. All right. Thanks very much for listening, everyone. Thanks for your time. Thanks, Chris and Ben, for joining us today. It's been a pleasure as always, and I hope to see you again at the next podcast. Thanks very much.
Bye, everybody.
Bye.